things here. I don't need these anymore. I don't need this anymore. Get all those out of the way. Yeah. Now I've got all sorts of working space.
So we leave the test tube in the centrifuge for like 20 seconds.
Yeah, you'll hear it. It sort of builds up speed, and then it reaches a high speed, and then you just leave it in there 5, 10. Sometimes you'll take it out and you'll look at it, and it'll be all cloudy yet. There'll be some precipitate settled out, but the rest will be still cloudy. That means you have to put it back in, centrifuge longer. Different precipitates centrifuge out at different rates. This silver precipitate in procedure 1 is one of the better ones to work with because it settles out pretty quickly. Okay. So now I've got my test tubes in here, and I want to make sure I distinguish between my counterbalance. Ideally, what I would do is label my test tube. I'm going to my lab book. Here's my data table. Where is it? There it is. Way up there. I'm going to put it down just a little bit so I can write on it. And I did procedure 1, cold dilute HCl. I looked at it. I got a white precipitate, colorless decantate. Oh, I wrote it already. White precipitate, colorless. I can't decide. If I wouldn't have got any precipitate at all, and I was really careful with water, I could say lead is absent, but I don't know that. So that's all I can say right now. So I don't put anything over there. Then I go to procedure. Oh, I'm not done with procedure 1. Oh, darn. I skipped 6 pages. Okay. It says wash down the precipitate from the sides with a few drops of water. Don't do it. My instructor always let me do it, or let everybody in the class do it. And what we discovered is, because of surface tension, the precipitate climbs up. When you try to wash it down with water, it just climbs up the test tube higher and higher. So instead of having precipitate down here near your water, now the precipitate is up here. You wash a little, try to wash it down, it keeps creeping up the side of the test tube. So it goes along with what I said before. You're not adding any extra water. Okay? So he said, and the other thing he said was mix the contents thoroughly with a glass stirring rod. What I did was I just flicked the test tube to get things mixed, which I described over there. Now he always has little notes that explain some of the things that I'm saying here. You want to read, pay attention to the notes. So the first note where you get to it, he's just telling you lead is soluble in water, or slightly soluble. So if you start adding too much water, you're possibly going to lose your lead, which is something I already said too. But the next step, which I almost skipped over, test for completeness of precipitation by adding another drop of 6 molar HCl. Okay, I described this to you over there. Now I have to do it. So he's describing it if you don't do it. I tighten the top back down, and I make sure it says HCl because people always move these bottles around, except I am the only one working here, so that's where I put it just before. But you come back to the reagent shelf and put it down one place, and it ended up in a different place. Make sure I get a nice smooth drop. Oh, there it is. Okay, the drop went in, went to the bottom. You can see it sort of mixing because of the difference in the index of refraction, and no white precipitate. Now, one of the things people sometimes say, well, there's a little bit of white precipitate on the top surface. That's the meniscus of the liquid. Because of the surface tension, sometimes you get really light particles of precipitate. They can't break through, but they're so light that it really doesn't amount to anything. If you lose it or not, it doesn't matter. If if you're trying to save this for the next procedure, of course, you want to get rid of it so it's not contaminated with this precipitate. But I'm reading right along here. I check for completeness. No more precipitate. My precipitation is complete. Centrifuge, I already did that. I'm going to decant. Now the only thing that's in this test tube is excess HCl. That can go down the drain. The other thing that's in there are the extra nitrate ions. That can go down the drain. However, and so if I was really rushed and trying to do production line things, I just decant into the sink. But if I decant my precipitate into the sink, I'm going to be in trouble. So I'll get a clean test tube and decant into the clean test tube. That way if something goes wrong, or if I have to save the decantate, I'll have it in a clean test tube. And like I said, if the precipitate goes over, oh, it almost went. But it's a good sturdy precipitate. It's still there. Trying to go. Okay. Precipitate's here. This is the can. I'm going to throw that away in a second. And there's a fair amount of liquid in there. And if I were doing any other procedure, I would wash it. But I didn't add anything unusual to this. I only added the ions that are in this procedure. In other words, the silver, mercury 1, or various combinations thereof. And so you don't have to worry about washing impurities away in this one. And I'm more worried, and you're more worried about losing lead. So don't worry about the washing step. Okay. So you don't want to do the washing step. So I've gotten most of the decantate done. As I say, if the precipitate keeps insisting on transferring, then you want to use one of your pipettes to separate the liquid. Okay, so I've got my precipitate here. My water baths are ready. The note here, continuing on reading, by the way, centrifuge decant, which I didn't do, says they save the decantate which contains cations that follow. What did I say about that? We're stopping at procedure 4. So there's no reason to save anything for procedure 5. So I'm going to discard this. Now, if I don't know what's in here, if I'm not sure, there's big bottles in front of each of those backsplashes on the sinks there. Those are for all our waste solutions. So if in doubt, put it into the waste solution bottle. We send those off to be disposed of properly. But this I know is just HCl, so I'll flush it down the drain with a little water. And don't pour it in the back part of the sink, pour it right down the drain hole. And you want to be careful when you turn these things on because they generate a lot of pressure and spray all over the place. And I'm going to rinse this test tube out so I'll have a clean test tube for later. That's one of the things. Actually, I don't have to because I have a lot of clean test tubes. But that's one of the things you would consider when you're doing your experiment, because you always want to have clean test tubes for the next step. And so sometimes, I guess, if it's got a lot of dirty test tubes, you can spend some time cleaning test tubes. And I didn't use soap and water because I know all I had here was HCl and water, so I just rinsed it a couple times with distilled water. So it's ready to go for something else. So I put it where I keep my clean test tubes. Oh, one of these racks, I'll put it in this rack. My clean test tube. I'm ready to go to procedure 2. That's where I separate silver from mercury. It says add 15 to 20 drops of hot water. Okay. I'm going to use one of these pipette type eyedroppers, so I'm going to add about 30 drops. Okay, maybe a little more than that. Not really critical. Stir well. If you don't already have a stirring rod in your locker today, don't worry about it. On Wednesday, at one point during the lab while you're working, I'll say if you don't have a stirring rod, now's the time to get up and get a stirring rod. At another time, I'll say now's the time to get a clean pipette. I'll give everybody one clean pipette. You might have 2 or 3 other pipettes in your locker already. Okay? Depends on how many were left by the other students. Okay? If I have a clean stirring rod, if I'm not sure, I clean it. How do I clean it? Mostly rinsing with distilled water. And since if I clean both ends and handle it in the middle, I can use it twice before I have to clean it again. There are all sorts of little things you can think about while you're doing this experiment. I have a little clean piece of paper towel where I keep clean things. I'll put it on my clean piece of paper towel. I'm just making space here. Okay, I've got my water ready. I've got my well, I don't have my pipette ready. I need a pipette ball. By the way, these things, because of the acid fumes and everything, do break down. So if it doesn't squeeze or pump liquid up your pipette or whatever, get a new one to replace those. Don't struggle with something that's broken. Now comes one of the tougher ones. I'm going to use this for my water bath. The beaker is the water bath. The flask is the distilled water that's clean. Okay. Okay, that was about 20 drops. I need about 10 more. I think I can do this left hand. With my sore shoulder, my right hand is getting worse and worse. Okay, let's switch hands. I'm mostly right-handed. Yeah, that works better. Okay, there was about 10 drops. Actually, that's a little bit more looking at it. Okay, that's just distilled water. It was my clean distilled water. In my clean area. Darn, the precipitate isn't breaking up. Remember I said that was a really solid precipitate. I'm flicking the tube and nothing's happening. So I take my clean stirring rod and break up the precipitate. Okay, I guess this is, when that goes off, we turn off the gas, make sure everything's secure, and you can leave things here. I'll lock the door up, you take your coffee or something, and we go out that door, down the stairs, and into the open area. And then I will lock the door when we come back.